Hey everyone, I'm Simon, and I love art, which you already know if you watch this channel, but what you might not know is that I also love math. And I spend a ton of time on Desmos Graphing Calculator. It is an amazing tool. I use it for all sorts of stuff, both solving problems and, as I'll do in this video, just making art. In fact, I've made so many Desmos graphs that I could scroll for quite a long time if I wanted to show you them all. But in this video, I'm going to be focusing on the graphs that I find most beautiful and artistic, so you don't necessarily have to have a math background to understand them, but I just think you'll appreciate how pretty they look and how cool it is that you can make art out of pure math. And this is my first one. This is actually a project from a class I took a few years ago, and it was our final exam project, but it's really part of what got me so excited about Desmos to begin with. I made a little wolf out of all of these equations, mostly hyperbolas. Some of them rotated and other stuff, but this was a really fun project. The second one is a beginning of a series of animated graphs. This one is an incredibly satisfying graph I discovered a long time ago that basically just speaks for itself. I mean, it's obviously running a little slow right now, but you can see it's pretty awesome. And look at that equation too. I literally just found this by messing around. Same with this one. I found this one not too long ago, and it's just, look at the way they hop from one to the next one. I mean, yeah. I apologize if my commentary isn't the most unique in this video, but these graphs are awesome, and some of them do need a bit of an explanation, so I'll be talking about them. Others in here also have some interesting stuff, but mainly this one because it actually changes over time. And then this one gets a little wacky, but it's also really interesting. So yeah, that's that one. So this graph is pretty straightforward. It is just a bunch of concentric circles that, due to a bit of clever math, infinitely repeat. So it looks like you're either zooming in forever or the circles are zooming out forever. But they're all different colors, and I just think this is a really fun application of polar coordinates. This one is kind of from physics. It's just showing a transverse wave moving, but I think it's so fun to watch and see the little sphere in the middle going up and down. I think it's one of those simple graphs that's just so satisfying. This one is basically just a sinusoid that I started messing with basically it's an exponential in a sinusoid. And the neat thing about it is it kind of just looks like syrup drizzling or something, you know. It's just really fun to watch. There's something amazingly satisfying about that one. So this graph is a little more straightforward. It is just some fish that I found by messing around one day. It's just, you know, this sinusoidal trigonometric equation you see here, but it's fish. It's like the generic way to draw fish that you learn in elementary school. I thought that one was really fun. Same thing here. It's just completely me messing around, but there's a little diamond, and I think that's really cool. It's just a beautiful graph. This one is actually an audio I made. Again, not too difficult of an equation, but when you plug it into Desmos' audio converter, you end up with a really neat little sound. So yeah, just pretty neat. This graph is just another one I found by messing around with functions. It's just a really neat combination of equations in an implicitly defined graph, and it kind of ends up looking like stones in a river. Like, you know, here's your river and it's emptying out into an ocean or something, and there's stones. I don't know. I just think it's really cool, and such a fun little equation, and you see it ends up becoming just a sinusoid. And that one gets bigger and bigger over time. So just a really interesting graph. I really enjoy that one. This one is literally just a person. I originally graphed this equation and found that it looked like it could be hair and a body. So then I added in a circle and a couple other circles, and then I added in a parabola, and you got a person. Happy little smiling gal or guy. This one is a triangle. I did not come up with this equation for the triangle, but what's really special about this graph is the other ones that are in it. So there's also this one that's just a really sharp corner that goes off for infinity. I think that's the most satisfying thing. This one that's just a parallelogram, and this one that's just so interesting. Now this one I also just kind of found by chance, but it's just a rectangle that oscillates up and down. But again, it's one of those simple graphs that's just so satisfying. And the equation is not simple at all, as you can see. It's sine of t e to the negative absolute value of cosecant of t times x all to the power of a, where a equals 1,000. But the neat thing is, of course, you can see that the area under this curve, that's what that integral I represents, does in fact equal what you would get when you calculate just a rectangle. So it's kind of interesting that that approaches an exact rectangle. So I guess we're getting into more of the math area now, but hopefully I haven't scared you if you aren't into math. I did not come up with this equation, but I love it so much I had to include it, and that's not even an intentional pun. It's a beating heart. It's just a heart that slowly fills with a sinusoid and beats over time, and I think that's beautiful. This graph was an idea I had. So I was wondering, what would the graph be of this formula, right? So y equals e to the x plus sine of e to the x plus sine of e to the x plus sine of forever. And as it turns out, you can take y and just plug it back in here to implicitly define this graph. So you go from this messy thing from the version that's incomplete to this really interesting implicit graph that ends up just becoming a sinusoid, but it's just really kind of awesome that this crazy looking equation ends up looking so beautiful. This one was actually a solution to a differential equation. I came up with this when I was bored one day, and I solved it in Desmos, and it turns out that this is the solution, and when you plot that solution with a series of initial conditions or constants, you end up with this really cool looking implicit curve. And I just think that that's such an interesting, like, beautiful solution that if there are any systems in the real world that behave with this differential equation, that this is their graph, and it's just this beautiful, interesting convergence. This one is, so this one does use a little calculus. This is, if we imagine what would e to the power of x minus x squared minus x cubed minus x to the fourth minus x to the fifth minus x to the sixth, and you might expect that that would just be 0 because you're subtracting x forever, but of course it's not over a certain interval. And with calculus, we can figure out that this sum is actually over a small interval equal to this equation. And so the continuous result is that e to the power of this forever continuous series is this really beautiful and kind of elegant curve that just goes up and then down. And I think that that's really awesome. I also did a little more math and found that the maximum value of this curve is at exactly 1 minus 1 over the square root of 2. That's this point up here, which I just think is cool. This is a graph of a spring that I kind of came up with for fun. I wasn't trying to make a spring, but I ended up making one. And I think it's really cool. Obviously, the equations are crazy complicated. I just messed around and made them up, but it's this spring-looking thing that just bounces all the way up and then comes back. And that does actually go out to infinity as this approaches 0. So that's just a really fascinating one. This graph is a bunch of ovals that just kind of pop into one another forever, and it's super satisfying the way they just glide across the screen. I apologize for my awful frame rate, but I am recording at the same time. Hopefully the actual video will be a little better, but I think this one's just awesome. And again, a really interesting, elegant equation. This was derived originally. I started by thinking of the formula for sine of 2x, that equals 2 sine x cosine x. And I sort of went with that and changed a couple parameters, and you got this really neat implicit curve. And for this one, it's similar to the one I showed before with concentric circles, except it's just an endless spiral. And it does repeat forever the way I set up the periods. So it's just an infinite spiral outward. And if any of you have played Run 2, if you were cool math games people, it's kind of also, you can imagine yourself running down some infinite corridor, spiraling down to infinity, or up. And this one is just an amazing equation to look at. I think it's so cool to see, especially if I invert the colors. Just such a cool graph. So proud of that one. And Desmos has a 3D version now, which is amazing. I love it. They also made it when I started my multivariable calculus class, which was perfect timing. And in this version, I have made a bunch of cool stuff. So the first thing actually I'm not going to show is that one. That's the last one. Is this really neat looking shape. It's just such a cool shape that I just made by chance doing this. Again, implicitly defined. But it's just really neat. And it's the little things like that. It's kind of like the tip of a golf club, but it's just a really cool shape. And this is another satisfying graph. A little straightforward, but just that just looks beautiful, especially the way that the texture that Desmos puts on it. It kind of looks like candy or licorice or something. I don't know. Just very fun graph. And last but certainly not least is this actual electric field that I programmed with radial vectors. And I manually programmed a vector at each point in the coordinate space. So I had some equations defining them and all this stuff. If you're into physics, you are probably nerding out right now. This is great. I love this graph. And of course, right now it's defined for a point charge. Obviously, I couldn't define it for the entire coordinate plane, or my PC wouldn't be able to handle it, and I would have to take a lot of time because I had to do each of them individually. But doing some cool math here, you can actually just show the electric field vectors. And this isn't just a physics thing, it's also a beautiful thing. It's really cool to see all these vectors coming out, and especially as I change the value of the charge, to see them extend out longer and longer is such a cool visualization for anyone, especially for people who are learning this stuff for the first time. It's just beautiful. And in fact, you can set this equation to be anything you want. So you can make it some really interesting graphs here where it starts to look a little funny. But of course, the typical one would just be Q over R. And so yeah, this is the last graph in my video. I hope you've enjoyed it. I know I have. I love making these. They are a time waster of sorts, but they're so intellectually stimulating and fun. If you found this video fun, I would definitely encourage you to make your own graphs in Desmos. I think it's an amazing tool, and I absolutely love them. I'm not sponsored, but they're awesome. And keep on going, make art, enjoy life, and I'll see you in the next one.